Alright, welcome to the first video on the TCP IP course as a way to understand and communicate why and what is TCP IP while using ShareWaves for network inspections. So I'm doing this course as a way to improve my ability to any time that a client needs to inspect the network, especially for web applications. That's my niche. I can do that easily, and any time that I am encounter is com- applications communicating across different servers, for example using Docker. Now I can is filter, or I can have a tool that actually is on demand in the industry, while now getting is the benefit of this, which is finally is inspect what I need to do, right? uh, Again, this is a tool that is very relevant to network people most of the time. I am someone from the server, okay, web server, using Node.js, especially in JavaScript. But as I move on down deep into the industry, and as I keep working with several clients, I realize that I need to know is a little bit more of how do I know how these two different entities, client and server, especially the more clients, the more servers you have, sorry, uh, it is very, very important how this communication is happening, what's going on behind the scenes, what is the data that you're getting to. In other words, is inspection here. Pretty much like a Sherlock for the internet, for the network layer. In this case, the TCP IP. So that's the reason why I'm recording this series of video locally for me, is that this is something that is public. So Chris Greer, so shout out to Chris Greer here, um, the instructor here. What the hell? Uh, Here, Chris Greer, shout out to him, because now, thanks to his contents and their experience, he published a video publicly available here on YouTube. And what I'm gonna do is to take bit of or take segment of this video, understand that, comprehend that, pondering all of this concept. So when I need to explain that to someone else, I can not only reference to, or I can not only is quote the content, but also the source, which is Chris Greer, which is also hosts a course in uh, Plural site. So you can take a look at that, and from there you can work on. It also has some videos on Udemy, as you can see here. But again, this is something that, if you want, okay, this is something more relevant for people that are on the IT operations, that are relevant to between the applications and the lower level layers on the OCI model. So something that we're gonna take a look at today's course. Uh, you got it. Course. You got it here. Okay. I want to add this reference here, from here. Okay, there you got it. Bound. Move on here. There we got it. So in today's video, I'm gonna focus on answer this why learn TCP/IP, what is TCP/IP, who owns it, and then in the next video, I'm gonna record myself is learning, or take a look at the TCP handshake, the options, And then down the line is TCP window scaling and case study and measuring app response time. So first thing first is why learn TCP? Let's go for it.
Now, intentionally, the first session, if you notice on your program, it's a one fin. So beginner level, we want to go in and talk about fin. First session, if you notice on your program, it's a one fin. So beginner level, we want to go in and talk about some of the TCP fundamentals. I noticed on some of the other sessions that even I attended, sometimes the instructor might say, hey, you know, it's just a window problem, okay, moving on. And if we're new to TCP, we're going, whoa, no, what does that mean? Or no, it's, you know, no big deal, SAC, you know, okay, there's SAC, there's this bit, there's that bit, and it's like, whoa, time, back up, hang on. What is that? What does that mean? How does it work? So we're not going to make any assumptions as far as your level of TCP experience and knowledge.
And I love it that you don't make any assumption here, because I'm gonna make a fresh start here. Okay.
We're going to spend this first session, one fin, going through those fundamentals and making sure that we thoroughly understand them. That way, in the second part of this session, when I start throwing some case files some case studies and showing you some of the things that I've seen out there, you can follow along and understand better what's happening. Okay, so to just introduce myself, you see my name there, but okay, my name's Chris Greer. I work for a company called Packet Pioneer. So I basically do consulting using trace files and Wireshark, and I also am a Wireshark instructor. So a lot of times people, they'll be having a problem, they'll find me through whatever means, sometimes my YouTube channel, sometimes the website, or different blogs that I do in the industry. They'll have a problem, sounds kind of like what I wrote about, and they'll contact me and say, hey, I got a problem, can I send you a trace? I just got a query last night for somebody in New York that's having a performance issue. So I'll do my best to help them out, and sometimes that'll turn into a Wireshark training class, which is great. So I'll say, hey, that's awesome, but how do I not call you again? So in a way, I'm kind of training myself out of a job, right, with the training part, but hey, that's what I like to do. I like to instruct as well. As I mentioned...
Okay. That's kind of what we're doing here exactly. Is like learning. Again, this is part of the dynamic nature of business. Is that right now we're barely uses pen and paper. Most of us would do that, especially for things that are very technical, where we need to keep track things. We need to have that mental model. But usually in our daily life, we barely use that, or at least on Western countries or countries that are now more technological advanced, they barely rely on pen and paper. That doesn't mean that you don't know, or that doesn't mean that you shouldn't know how to use it. Okay, but again, it's like as we move on with this new field of solving business challenge, right? We are going to, or we tend to forget, is what are the core layers. This is one of the issues that also Carl Sagan mentioned, especially as we grow up as a culture and we dive deep too much into the technological spheres as a way to solve material problems. We tend to forget is the core, where all of this come from. That's also the reason why I'm here. And as I move on to now offering is my service as a JavaScript developers for client and server-side applications. As anything in life, like business, it evolves. So that's one of the reasons that perhaps right now I'm actually is building applications using JavaScript for the client and the server. Perhaps in the next 5 years, I'll be doing something not completely different, but something that now the industry needs more. It pushed the boundary beyond that. All right, back to the video.
My YouTube channel, go out there and check it out, youtube.com/PacketPioneer, or if you just search for Wireshark or filters or that kind of stuff, you'll probably find it eventually. What I try to do on my YouTube channel is not do anything longer or much longer than 10 minutes. Because, I mean, let's face it, I have a tough time sitting through a 1 hour or hour and a half full, even the Shark sessions. It's just, I have a hard time finding that time to dedicate my brain to what's really happening in that video.
Well, in my case, I don't have that issue. I had that, not right now, especially because if you're going to measure, one of the best things, or one of the best assets that a software developer has in a person is their time. Because of that, anytime you're going to dedicate to a topic, I prefer to better off be with that as long as it takes for a goal, for a context, and then I can do something else. And as I do this process over and over and over, so the more exposure I am to this over the days, now I started to realize, hey, okay, now it makes a lot of sense. Now I know how all of these different things connect each other, so I can solve the particular problem that I need to solve. All right, move on.
So what I try to do out there is just throw, I'll call them shark bites, even though tomorrow we have shark bites technically, but I try to just throw an idea at you. Here's a 5-minute, that's all we're gonna cover. And then boom, 5 minutes, 10 minutes. So if any of you guys are out there who have seen those videos, please come up and chat with me on one of the breaks or afterward. I'm always interested in ideas or things that you might be seeing out there that would be useful to have a video for. Sometimes I create those videos on behalf of my customers so that they can better explain what's happening in their trace file using that video. So for example, I say, oh, you just have a receive window problem. And instead of them needing to go to their boss and say, hey, we've got a receive window problem, instead they can watch.
Wait, what?
So for example, I say, oh, you just have a receive window problem. And instead of them needing, so that they can better, sometimes I create those videos on behalf of my customers so that they can better explain what's happening in their trace file using that video.
Exactly. All right. So this is a specific goal. Specific goals here. Yeah, specific goals here. Specific goal here is that improve my communications
customers so that they can better explain what's happening in their trace file.
Okay, so explain better explanation to customers, to myself. Okay, better explanation to customers of what's going on in trace file.
Using that video.
Okay, of what's going on in trace file. Question is, what is a trace file? It's like question. Q&A, it's like Q&A, right? It's a Q&A. What? You got it. Q&A. What's a trace file in Wireshark? In Wireshark context, I think is the output of this.
So for example, I say, oh, you just have a receive window problem. And instead of them needing to go to their boss and say, hey, we've got a receive window problem, Instead, they can watch that 5-minute video together, and then I do the heavy lifting for you. So anyway, video together, and then I do the heavy lifting for you. Instead, they can watch that 5-minute video together, and then I do the heavy lifting for you. So anyway, I'm absolutely open to suggestions in that way as well. Okay, what are we going to cover? We're going to talk about why TCP is such a critical protocol.
Okay.
Why is it something that, hey, a lot of us are in here, we're interested in TCP, we're interested in how it works, we're interested in how it...
Okay, this is specific goals here. All right. Or customers here. Trace files. The other is, well, why is TCP such an important protocol to understand? Why learn TCP? Okay.
Delivers data. We're interested in looking at one of those screens like we've seen over the last couple of days, and the instructor stops and says, okay, you see the problems right there? I don't know, maybe you like me, when I first started coming to SharkFest, I'd sit in those sessions and I'm looking at the screen and I'm thinking, honestly, I don't see what's going on. And they're just running through this trace and I'm just like, wow, okay, maybe one day I'll get there. Well, if that's how you feel sometimes, I mean, hey, I feel that way too sometimes at these sessions. Especially when someone's moving through a trace really quickly. So what I want to do today for you is to get you a bit more comfortable with what TCP does, how it works, some of those underpinning things that we should know to then be able to build on later. Those underpinning, comfortable with what TCP does, how it works, some of those underpinning things that we should know.
Okay, why learn TCP? Especially with Wireshark.
With what TCP does, how it works, some of those underpinning things that we should know to then be able to build on later. Some bit more comfortable with what TCP does for you is to get you a bit more quickly. So what I want to do today for you is to get you a bit more comfortable with what TCP does, how it works, some of those underpinning.
Okay, so why learn TCP? So what TCP does? Exactly. So what TCP does, what's the underlying
things that we should know to then be able to build on later. Okay, so we're going to be talking about the handshake options with.
Okay. Specific goals here. Core concept. Very. Oh my god. Okay, core concept. TCP handshake and option, TCP window and TCP retransmission, and selective acknowledgement. Oh my god, this is it. Oh crap. Okay, so here we're gonna learn is this. Okay, why learn TCP? What is TCP? Okay, and then we're gonna learn is the core concept. Okay, core concepts of that, and that is the TCP handshake. Yeah, TCP handshake and options. TCP handshake and option. TCP windows. TCP retransmission. TCP retransmission. And selective acknowledgement. And oh my god. Selective acknowledgement. Acknowledgement. I'm not sure if I wrote that. Acknowledge. Oh my god. Exactly. Acknowledgement. exactly, is acknowledgement. I think I'd add an unnecessary D. Exactly, selective acknowledgement. Okay, this is part of the course here. This is the goal. Specific goals. QA. Okay. We're gonna take a look at this. Why? What is this? What is a TCP? As well as the core concept. Then you got is this, as well as this, and this, and this. Alright? Which is something that we mentioned here, as you can see here. And then the case of study. TCP handshake, and then exactly TCP handshake and options. Oh my god. TCP handshake, TCP option. They put it in the same, which is interesting. TCP handshake, TCP windows. God, why is that? Why'd you jump that? And then selective acknowledgement for that. And then the case study and measuring our app. Okay. And then the case study here. And then the case study, and then measuring app response. All right. Okay, that makes a lot of sense. Okay. TCP/IP course. Okay. Oh. All right, move on.
Within the handshake, TCP windows, both receive and congestion. We're going to talk about retransmissions, how those work, selective acknowledgements. Okay, so some core things. Now, you might know some of this pretty well. You might know it cold. But I think an important thing with TCP, and one of the reasons why you see a lot of these instructors do what they can do here up on this stage, or even with a trace file, if they are sent a trace file and they can just like Hansong, he can just rip through and go, oh, 30 seconds, you know, he takes 30 seconds and bam, I found the problem. It's because he knows the fundamentals really, really well.
Exactly.
He knows them cold.
That's one of the reasons why, you know, you can provide value, especially in the technological or in the tech sphere. You can provide that value. You can be the guy or gal or the man or woman to be called.
Right? He knows how it's supposed to work. That way when he sees a trace file that's struggling, having some problems, he can more quickly spot the problems in that trace. Okay, so that's why we're doing this today. We're going to go over some of these fundamentals and then make sure we can really understand what they're doing. Again, this is in session 1. As we get into session 2, we'll do a bit more with case studies. Also, tips for isolating performance issues. This is the TCP tricks part. So creating a TCP profile. In Wireshark, how can we create a profile that can help us to find some of these issues faster?
Tips for isolation performance issue. Okay. Say tips. The tips for isolation. Tips for isolation performance issue. Performance issues. Okay. Which is this? I think, yeah.
What filters can we set?
Creating a TCP profile color. Okay. Creating a TCP profile. Okay. Colors. filters tips in Wireshark. Okay, filters tips in Wireshark. Tips in Wireshark. Okay, filter expressions. For example, like this. Okay, filter expressions, spotting delays in TCP streams. And spotting delay and spotting delay in TCP streams. Okay, that makes a lot of sense. So this is one title, this is another, and this is another, right?
Spotting delays in TCP streams, so I've got a handful of things there for you. And of course, case studies like I mentioned. All right, so first of all, TCP, why is it a big deal? What's the reason why we're all here? Why are we interested in TCP? Well, important stuff uses it, at least for now, right? So it's reliable, it's connection oriented, it's going to ensure that that data gets over there, and we...
Okay, so why TCP? You say why TCP is a big deal. Okay, it's a big deal. So why TCP is a big deal? Important stuff, use it. Yeah, so important stuff uses it for now.
Get a positive acknowledgement, our stuff, that data gets over there.
Exactly. Is the way how that data gets there, a client or a computer, a device, to over there, another device. Okay,
and we get a positive acknowledgement, our stuff got there.
And we get a positive acknowledgement. Our stuff just got there. Okay.
Also, TCP handles loss and congestion relatively well.
Okay. So also TCP handle loss and handles loss and congestion really well.
If TCP is smart, it can figure out, okay, I just sent some data on the wire, I sent it at a certain rate. I started this the wire, I sent it at a certain rate. I started to sense some congestion, I saw some loss. Let me back off a little bit on how much I'm sending. It wants to figure out, especially with a large data transfer, it wants to figure out what's the best rate that I can send this at without running into problems.
It can it can render it can
figure out what's the best rate that I can send this at without running into problems. So best rate with a large off a little bit on how much I started to sense some congestion, I saw some loss. Let me back off a little bit on how much I'm sending.
Okay, really well. it is pretty smart because because
sense some congestion. I saw
because it can sense congestions, okay, because it can sense of congestions and losses.
some loss. Let me back off a little bit on
Some loss.
I started to sense some congestion. I saw some loss. Let me back off a little bit on how much.
Okay, so let me back off a little bit. Okay, so let me back off a little bit
Much I'm sending.
of how much I am sending. How much am I sending? How much I am sending is this. I am sending.
It wants to figure out, especially with a large data transfer.
It wants okay. It wants to figure out, especially on large data transfer, at what is the best rate to send it.
It wants to figure out what's the best rate that I can send this at.
Yeah, it wants to figure out, especially at large
transfer. It wants to figure out, especially with a large data transfer.
Exactly. It wants to figure out, especially on large data transfer, what is the best rate that I can send at.
It wants to figure out what's the best rate that I can send this at.
Okay. What's the best rate that I can send this at?
Without running into problems.
Exactly. Without running into problems.
So TCP is a smart protocol. Now, how it does that and interpreting what we see on the screen, that's what we're here to do today. What we see on this smart protocol. Now, how it does that and
exactly. Question is that how it does that. So we need to take a look at what is, after all, the TCP and IP. So TCP stands for TCP, so transfer control protocol. Okay, so according to Cloudflare, is that this cloud service provider for hosting solutions, hosting edge networking solutions, right? So they have a bunch of solutions here. So it's not only it's exactly because you have a lot of it. So my topic is like risk postures, digitalizations, AI, cybersecurity, data compliance. So now their solutions is not only. So this is a cloud server service provider that covers this topic from cybersecurity, AI, e-commerce, hosting, that kind of thing. All right. Okay. It's now in the field. What? Why did you change that like so? Oh, I get it. Okay. So is that. So this is the transmission or transfer. Is it transmission? Transmission, and with that is not ETS. It's transmission protocol, control protocol. Okay. And so yeah, this is a transmission control protocol. So IP does not handle package ordering or error checking. Such functionality requires another protocol, which is a transmission control. The TCP is taking care of that. So it's smart enough to say, hey, it can sense congestions over the network, some losses. So let me back off a little bit on how much I need to send. So it's especially good, okay, or it wants to figuring out, especially on large data transfers, in plural, okay. So it wants to figuring out, especially on large data transfers, what is the best rate I can send, okay. So what's the best rate that I can send, with D. So what is the best rate that I can send this without running into problems, okay. And how it does that?
And interpreting what we see on the screen, that's what we're here to do today. So TCP is a smart protocol. Now how it does that, and
now how it does that. Okay, and then you have is the IP, something that is quite familiar, the IP, which is the internet protocol. Okay, so the second, the first, so TCP's job is to handle how data is going to be carry on. It's going to be sent over. So pretty much like holding service, right? So pretty much like holding service. They take a content, okay. Like some sort of holding services. He doesn't use the holding service, but we can perhaps use the holding service. Okay. Pretty much like holding services. But this, no, it's not like holding service. Pretty much like holding service. And the dispatcher, like field service management, okay. In the IP's job, okay, in the IP's job, let me in fact actually quote this, because I think this is something very, very important as a way to understand what is this, okay. So the TCP/IP relationship is similar to sending someone a message reading on a puzzle through the mail, right? The message is written down and the puzzle is broken into pieces. Each pieces they can travel through different postal routes, some of which take longer than others. When the puzzle piece arrive after traversing different paths, the piece may be out of order. IP makes sure the piece arrive at their destination address, and TCP can be thought as the puzzle assembler on the other side, who puts the piece together in the right order, asks the missing pieces to be resent, and lets the sender know the puzzle has been received. TCP maintains the connection with the sender from before the first puzzle piece is sent to after the final piece is sent. So IP connections IP is a connectionless protocol. Alright, so TCP is a connection-based protocol, while IP is a connectionless protocol, which means that each unit of data is individually addressed and routed from source device to target device, and the target does not send and acknowledge back to the source. That's where the protocol such as TCP comes in. TCP is used in conjunction with IP in order to maintain a connection between the sender and the target to ensure package order. So this might be the a good example of this. So the TCP IP relationship, like so. So the TCP, you guys, this. So the IP is a connectionless protocol, okay? Which means that each unit of data is individually addressed and routed from the source device to the target device. And the target does not send and acknowledge back to the source. Okay. TCP is connected. It's connected oriented. Whereas the IP is, as I mentioned here, connectionless. Connectionless. It means that it doesn't need to be connected to send data to that. For example, when an email is sent, it is established a three-way handshake is made. First, the source of the sync initial request, then start the dialogue, sync and acknowledge package, and then you get it. So the primary version of IP used on the internet today is Internet Protocol version 4. Due to the size constraint with the total number of possible addresses in IPv4, a new protocol was developed, and the new protocol is called IPv6. It makes many more addresses available and is increasing in adoption. All right. So we starting to develop our sense here as a way of this particular protocol, the TCP, which is connection oriented, is quite smart on especially large data sets, because it want to figuring out what is the best rate at what I can send this. Yeah, what is the best rate that I can send that? You know, so what is the best rate that I can send this? Yeah, what is the best rate that I can send this at without it running into problems? That makes sense? Yes. So he can sense if there is any congestions and losses. So where the IP, since this is a connectionless, it doesn't require that you already are connected. So package can be losses, because if the other person is not there, it's like, who you talking to? You know, it's like calling here someone, hoping. It's like calling someone and then talking without the other person be on the other phone, be online, be on the other side of the phone. He's like, yeah, you know what? I would like to order a pizza, and that should be, and there is no one else in the phone. Okay. All right. So that's the subtle difference between the TCP and the IP. All right. So the TCPs, both of them are protocols in the network layer. Okay. But no, I mean, TCP is a protocol on the network layer, on the transport layer. Okay. Where again, this is connection based or connection oriented, and it's smart enough to sense is there congestion of the network or there's some losses, so I have to back off a little bit. Again, the whole idea of this is that I'm going to send data through that. Okay, I'm gonna send data. Yeah, I'm gonna send data. What is the best rate what is the best rate to send? Okay, so what is the best rate that I can send that? What is the best rate that I can send this data at without running into problems? I think that's definition is something that it can summarize this, and something that I really love about that. Okay, and there you got it.
And interpreting what we see on the screen, that's what we're here to do today. Now today, I think the number one reason I get called anyway from my clients is because just stuff is slow, right? We all hear that. I still haven't ever gotten a call from somebody telling me things are too fast. This is probably why they point the finger at you. Could be why you're here at SharkFest. No doubt, this situation has led you to look at packets, right? As we're going to go on to talk about, from a network engineering perspective, a lot of times we just get the blame, don't we? And if we don't get that, if we are not to blame, then a lot of times the onus is on us to show who is to blame, right? It used to be 10 years ago, we could just say, it's not the network. My stuff's great. Not anymore though, right? Now we need to facilitate the next step of troubleshooting. Okay, if it's not the network, then what is it? Right, so back to us, back to network people. By the way, network people, raise a hand if you are from the network side of the house. Hands up. Woo! Okay. Server people, application developers, we got, hey, man, raise the hand, buddy. You're good. 2, 3, 4-ish. Wow. Notice who's coming to SharkFest. I mean, it's great to have you. Awesome. But yeah, so network people realize we're the ones that have the feeds. We're the people that path the packets on where they're supposed to go, right? So we're responsible for collecting them, capturing them, and understanding them. Mm-hmm. One time I was working with one of my customers who grabbed the trace file. He's a network guy, right? He's able to download Wireshark, put it on a box. He gets it in the path of packets, which is a whole nother conversation. Gets in there, grabs a trace file, looks through, doesn't find any retransmissions, and he figures, well, my network's fine, it's not me. And then he emails that trace file to his application guy. So I said, okay, what happened next?
Oh, okay.
I know you just sent it over this wall to the other side of the house, but what happened? I mean, what did he do with it? He says he didn't know. So he goes over there, talks to the application guy. So what'd you do with it? What'd you find in those packets? What'd you find in that trace file? Applications guy, I don't know what that stuff is. That's all your stuff. I deleted it.
Completely.
PCAP? The heck is a PCAP?
PCAP. Mm-hmm. Package capture. Oh my god. Okay, what the hell is a key PCAP? Okay, package capture. Never. Okay.
Right? So I was like, well, clearly that didn't have the desired results. A lot of times if we grab a trace and we can't quite figure it out, or if we exonerate the network and then send that trace to somebody else, sight unseen, that's not gonna do a whole lot of good, right? Network people are here today. That tells us something. Network people, we're responsible for owning the packets, collecting them, capturing them, and sorry, understanding them. Now we come.
Okay, this diagram to me was something interesting. because here we can see at a glance why do we need to learn this. For example, this.
Problem strikes, okay? OSI model on the right. Hopefully you have seen that OSI model before. When it comes to network engineers, if we're from the network side of the house, which most of us are, I grew up in the network side of the house. If a problem strikes, our goal is...
Come on. Question. No, take care, bye-bye. Exactly, the network engineering
is basically, and for all intents and purposes, our responsibility.
So Chris Greer, okay. So this is pretty much like understanding is the transport layer, the OC model, right? The OC model. I mean, sometimes can be quite boring until you figuring out what you can do with this, you know. So the OC models. So Chris Greer started his career at the network layer. So for example, this, like this. Okay, like this. What is the OC model? OC model. Yeah, oh my god. Can you give it to me in English? Yep. The open system communication. Exactly. The open system interconnection. Okay. The open system interconnection. Okay. Model is a conceptual model created by International Organization for Standardization. That's one of the reasons why the standards are helpful, especially when a lot of people wants to collaborate and usually get some money from that, which enables diverse communication system to communicate using protocols. Okay. In plain English, the OC provides a standard for different computer systems to be able to communicate with each other. So regardless the computer system that you have, so for example, examples of computer systems. Examples of computer systems here. Okay, so different computer systems examples like this. Okay, different ways or different systems that process data, that process arithmetic operations. Okay, different computer systems. Okay. Is a different configuration of hardware and software. Okay, that's the idea here. Okay, so so the OSI model is an open is an open system. It's an open system. Okay, it's an open system interconnection. Okay, the OSI model is an open system interconnections that provides standard. It's an open system interconnection that provide standards to a different. So the OSI model is an open source, is an open system interconnection that provide a standard to communicate to be able to communicate across different computer system. What does it mean, different computer system? Different different configurations of hardware, software. Okay, that's the whole point of that. Different additional equipments or peripherals. Like so, okay? So different configuration of hardware, software, additional equipment, okay? Different configuration of hardware, software, and additional equipment for data processing. Because that's the entire goal of this. For data processing in computing. Okay, that's the beauty of this. And that's so once you start to understand these fundamentals genuinely, then you say, oh, okay, now it makes a lot of sense. Why do we have this OSI model? Because we can have different configurations of software, hardware, peripherals, and we need to find a way to enable communication across all of these specimens, okay, so they can do their work, which is compute, data processing. So example of this, okay, so examples of computer systems are as they mention here. So you have mainframe, supercomputers. You have mainframe or supercomputers. Okay, mainframe, supercomputer, workstation, laptops. Okay, workstations, laptops. Okay, workstation, laptops, Windows, Mac. They don't actually Mac OS, exactly, because it's software or hardware. Okay, major type of computer systems. You know, example of major types of computer systems. So you have mainframes, supercomputers, workstations, laptops, Android, Mac, Windows. All right. You have also analog computers. You have also analog computers. microcomputers, mini computers. So you have mainframe, you have supercomputer, then you have microcomputer, then you have mini computers, then you have workstations, you have analog. A mainframe computer, informally called a mainframe or big iron, is a computer used primarily by a large organization for critical applications like bulk data processing for tasks such as censuses, industry and consumer statistics, enterprise resource planning, and large-scale transaction processing. So you have the mainframe, you have the supercomputer. Supercomputers come under the biggest, fastest, powerful, and most expensive type of computer for processing data. And then you also have microcomputers, okay, also known as personal computer. And then you have mini computers, standing in between the microcomputer and a mainframe. The mini frame, or mini computers. Okay, but this analogy here, so you have is, for example, example of type of computers systems. You have the mainframe, supercomputers, mini computers, microcomputers, or exactly microcomputers, or personal computers, PCs. You have workstation, you have laptops, you have Android, Mac, and Windows. But this difference, or this hierarchy of computing, processing power, is what gives now a lot of sense, a lot of context, especially when you need to find a way of how all of these different specimens, configurations of hardware, software, and peripherals, additional equipment, are combined together, and how you can now communicate each other. Okay, so how you communicate, how you can make all of this specimen communicate each other. So you need a standard, and a language, a protocol, okay, a way to do this. So that's where the OSI model kicks in. And so Chris Greer say, hey, you know what? I started my career here like that. He started his career as the network engineers. Okay? So the network layer, data link, and physical link. Something that I'm quite familiar with. In my case, I will go through that path, but then I end up resulting to go into this layer, the application, presentation, and season, as the server people.
Is to exonerate the lower three layers. We might put a little toe up into the transport layer with firewalls, but really when it comes to those lower three layers of transport, cables, switches, routers, making sure data can...
So network engineering, exactly. So network engineering are those who handles, exactly. Network engineers are those who handle, exactly. Network engineers are those who handle routers, switch, cables, make sure data reach from this computer to another.
Can get from there to there reliably. Data can get from there.
Exactly. So make sure the data. So make sure that data get from there to there. Okay, make sure the data get from there to there. Reliably,
to there reliably and with low latency.
Exactly, and with low latency. This is what a huge summarize of what the network engineers actually are doing behind the scenes. Okay, they actually make sure that regardless the computer system, regardless the specimen that is capable to compute, to process data, whether it's a mainframe or a supercomputer or a mini computer, perhaps a microcomputer, which is a laptop or a PC, a workstations, or whether it's a Windows, Mac, or Linux. Okay, whatever the configuration it is, whatever the specimen it is, they can communicate each other through a protocol. Okay, through a series of steps. And these protocols or these policies is known as the OSI model. The OSI model here, okay, is this model where allowed that communication. So it is made of several layers, okay, and to make things much more easy for business, for companies, and even for ourselves as a consumers, as a person, people that use them, this computer, we split them into server people and network people. So the network people actually handle is these low level layers, right? So the physical, the data link, and the network, right? So they make sure that, so this is the people that actually are going to the handle cables and switches and routers and make the data go from there to there reliably with low latency. That's very, very interesting.
If they go down to HR and they pull your job description, and there is a legitimate problem in those lower 3 layers, that's me, right? Hey, if there's a problem with Wi-Fi, if there's a problem with the switch fabric, the infrastructure, if I'm legitimately dropping traffic, okay, you got me. It's the network. So when a problem strikes, think about what your knee-jerk reaction is. What tools do you go to? How do you exonerate your part of this whole thing? Maybe you go and get a throughput tool, maybe you run some other tests, maybe you go over to some monitoring platform and you take a look for any red horrible indicators, packet loss. Do you have an interface that's flagging drops, discards? So if we don't see that stuff, we go up to our monitoring solution, everything looks green, it's SNMP based, I got NetFlow over here, I don't see high congestion. Monitoring solution, everything looks green. So if we don't see that stuff, we go up to our monitoring solution, everything looks green, it's SNMP based, I got maybe you go over to some monitoring platform and you take a look for any red horrible indicators, packet loss. Do you have an interface that's flagging drops, discards? So if we don't see that stuff, we go up to our monitoring solution, everything looks green, it's SNMP based, I got NetFlow over here, I don't see high congestion, I see low latency, I see things are up. Looks good to me, right? Then you tell them, hey, it's not my network. Well, we still got the problem. Okay? So we go to the other side of the house. Server peeps.
Okay. So this is the other side of the house. So we go the other side of the house. Okay, so we go the other side of the house to know. Okay, so we go the other side of the house to know what's going on if network people don't find any issues, which is this. Now where is Finder here? Which is this. Server people. Here I am. That's the reason why I'm here, by the way. It's like, what the is TCP and that kind of thing.
Pull out their job description, and let's just wrap those upper layers together. Let's call that just upper layers, session, presentation, application. They're in the server, the app, the virtual environment. They go in there, they check their resources.
So they check resource, exactly.
They're in the server, the app, the virtual environment. They go in there, they check their resources.
Okay. They are in the server. Yeah, they are in the server, the server, the virtual environment, for example, Docker. They are the server, virtual environments, and what's next?
They look at the server, the app, the virtual environment.
Exactly. So they are in the server, the app, the virtual environment here.
They go in there, they check their resources, they look at make sure nothing's spiked, no weird.
Okay. They check at resources, no spike in there.
Process, no backup sources. They look at make sure nothing's spiked, no weird process, no backups.
Exactly, no spike. They check at resource, no spike, no weird processes
happening. They go in there to their little world. To be honest, I don't have a ton of exposure into that world because I'm not a server app guy. They go in there, they check their stuff, and they say, hey, resource looks good, don't have any spike processes, memory's all right. It's not me. And what do? Well, they dump it right back onto you. This is a network problem. My stuff's great. Do we notice a layer that neither side is really taking ownership of? This whole conversation came because traveling around, talking to people, helping to troubleshoot issues, this is what I see over and over and over again. Sidebar, I'm not saying all problems are in the transport layer. I'm not saying that. What I am saying though, neither side of this house, I mean, IT has become very siloed, right? You're this kind of expert, that kind of expert. You're app, VM, network, Wi-Fi. You have all these fields of responsibility. But where's the TCP guy? I mean, think about it. Your company is running mission critical. If anything happens to these applications, if they slow down, drop, can't connect, we're in big trouble. These applications are using TCP, but who's the TCP guy? I'll sit down in a conference room with a whole IT department. So who owns TCP? No hands. Like, oh, there's that redhead stepchild that no one really wants to grab and own. So the fact that you're here at SharkFest and the fact that a session like this caught your attention means that that's now you. You're the TCP guy or girl. And you know what? Grab it, own it, live it, breathe it, become an expert at the transport layer. Why? Because you're gonna be the one that can fix some stuff. You're gonna be the one that can answer the unanswerable. You're gonna be the one that they go to.
Yeah, once once you know what the transport layer does, you're going to be the person. Okay, that makes a lot of sense. So once you know, oh, and this is also that, look at this, the things that I'm learning here, I will continue to pay dividends in the long run. That's one of the reasons why I also dedicated my time to learn the part of the server application, this upper level on the transport layer, okay, and the transport layer, because the things I'm going to learn here, I'll continue to pay dividends along the way. Because let's face it, no one lets suddenly stop using a computer. No one will say, hey, I want things to be slower. That's interesting. That's interesting. So once you know what the transport layer does, you're going to be the person that can solve problems.
Like, hey, that guy got that thing real fast last time. Let's go back. Where are they? Where's the packet person?
Where is the package person?
Right? So for me, personally, in my career, that's why I started focusing on the transport layer. I started getting deeper and deeper into this protocol because that's what I saw. It's like I go into an environment, you got the Microsoft guys, you have because that's what I saw layer. I started getting my career, that's why I started, right? So for me, personally, in my career, that's why I started focusing on the transport layer.
That's interesting. That's interesting. So, Chris Greener, I think is with two, Greer. So Chris Greer, since he start as the network guy, he slowly realized the importance to learn more and more, about the transport layer. Of course, because now you can do troubleshooting to improve troubleshooting. Because if you can solve, again, if you solve your own problems, then you can solve someone else's problems. That's all I can say. Yep.
I started getting deeper and deeper into this protocol because that's what I saw. It's like I go into an environment, you got the Microsoft guys, you have the app server people over here, you have.
Because he went to environment when they have the Microsoft, the Microsoft guy, the server guy, and a lot of them are guys. It can be women as well.
Have these like CCIE hotshot Cisco guys over here, and everyone's fighting, and we can't figure out the problem. And then these packet guys walk in, and they're just like, whoa, boom, there's the issue. And it was a TCP thing. So, there's the issue. And then these packet guys walk in, and
okay. Arguing about a problem. And then the packet guy
They're just like, whoa, boom. And then these packet guys walk in and they're just like,
yeah, and then the packet guys walk in and just boom, solve it.
whoa, boom. There's the issue. And it was a TCP thing. So inside your brain, as far as what you are responsible for within your environment, if your physical data link network, let's reach up, grab that transport layer and own it. Now, what you're gonna run into, one of the reasons why as network people we say, you know what, that's above me, is because that TCP component and everything that it does is within devices that we don't own. And it does, that's above me, is because one of the reasons why as network people we say, you know what, that's above me, is because that TCP component and everything that it does is within devices that we don't own in many cases, right? Where is the TCP stack? It's inside that box there. My network can't do much with it. I don't have the responsibility for shaping it or changing it. It's not generated by my network. However, to push forward as far as being analysts, it's something that we want to own.
Yeah. So as part of being analyst or someone who can solve problems much faster, it is important to know this. It is important to know this. I mean, this was a great review because it actually give me a lot of context, especially to improve my communication skills and when I need to talk to someone, whether it's a tech savvy or not, so I know what I have to do. I know how can I, especially in this field, say, hey, what is your expertise, or which side are you working? Are you the server person or the network person, you know? And then give to me and the other people, and perhaps non-tech people, which is after all, that's the end goal of this, to let also non-tech people know about this, okay? So explain things in simple terms, okay? I think this is by default the best way of how you can learn something. If you can explain in simple terms, most of the time it's because you understand it.
So if you find this in your environment, it could be, this is something that we want to grab hold of. Okay, so let's go ahead and start digging here.
Okay, so with that, that'll be all for this video. Take care. Bye-bye.